The last video was about resistors in series and parallel and just kind of what that was and what that looked like. This one is going to be a little bit more on that. So I've got this. If I have two resistors that are in series, I'm going to have some amount of current. I mean, I guess not on their own, right? If I stick a battery on here, I'm going to have some amount of current that starts at my battery. That current goes through this first resistor, and the current that comes out of that first resistor is the same as the current that goes in. Remember our beaded chain and moving each particle, each charge just down the line to the next location. That's all we were really doing with these currents, right? So each one moves to the next location. Over here it's harder to move charges out of their location. And if it's harder to move those out, then it's harder to move the previous one in. We are slowing down current in one spot, so we're slowing down current everywhere. Let's get back to it. So I have current that goes into my first resistor, and I have current that comes out of my first resistor, and those have to be the same as each other. Well, that same current then goes into my second resistor, and by the same logic, that same current has to come out of my second resistor. So what I see is that for two resistors in series, the current going through them has to be the same. So for resistors in series, the current is the same. I is the same. Which is why this is a physics course and not an English or grammar course. I is the same, look at that. So then what about parallel? In parallel, I've got current that comes up this way, but now it meets this junction. Now there is a rule, maybe rule isn't exactly the right word, but there is a saying that says that current chooses the path of least resistance, and there is truth to this. If this is a resistance, let's say resistance 1 is 10 ohms, resistance 2 is 20 ohms, then it's true that current will preferentially go through this top resistor, but it's not true to say that it'll all go through that top resistor. Think about this in the way of our straws, right? Resistor 1 is a straw that looks like this. Resistor 2 is a narrower straw. Now, if I use both these straws at the same time to drink my milkshake, it's not that none of the milkshake is going to come through here. Some of it will. It's just I'm going to get more through here. So, yes, current chooses the path of least resistance, preferentially, but not exclusively. So what I'm going to get some current that goes upward. We'll go this way for current that goes upward and goes through this resistor. Call that I1. And I'm going to get some current that goes downward. And call that I2. This I is the current that goes through my battery. So I'll call that one I bat. And I battery will equal I1 plus I2, which means in parallel the current is split. I is split. But in parallel, we do have this other thing. Each of these resistors sits on its own loop. So if I get rid of these, you can always pause a video and go back and see the picture with all the currents and things drawn in. And sometimes that can be a really helpful thing, but these pictures get really busy, so just try to make it a little simpler again. Back here, for the resistors in series, what I would have is that the voltage of the battery gets shared between these two resistors. So I is the same, V is split. Over here, it's the current that's split, but each of these sits on its own loop, meaning I can have current that goes this way, or I can have current that goes this way. But I can't have one current that goes through R1 and through R2. It has to choose. So the current is split, but the voltage is shared, or is the same. I'm trying to use the same language as before. Last thing about this. A parallel circuit likes to hide. Sometimes a parallel circuit doesn't look like a parallel circuit. This is still a parallel circuit. These resistors are not drawn like they are parallel to each other, but I have a current that runs through my battery. I see this spot where my current splits. That spot, by the way, is called a junction. So I see this junction where my current splits. I'm going to have one current that goes left. I'm going to have a different current that goes right. The left current keeps going. The right current keeps going. And then they'll come back together to make the current that goes through the battery. This is a parallel system, even though it doesn't look like it. Sometimes you will see a series system. This is less common. A series system where these are drawn specifically so that the resistors are stacked on top of each other like that. But if we trace out what current does, current's going this way, it has to go through this resistor. No choice, there's nowhere else for it to go. Still nowhere else for it to go. That same current has to go through the second resistor. These are in series. So the easiest thing, I think, to figure out just what's going on is to try and trace out a current. If I can trace out a current and it goes through one and it has to go through the second, then those are in series. If I can trace out a current and it goes through one and in doing so can't go through the second, then they're in parallel.